Hi, welcome to Introduction to Statistics. This is day one. I am Todd Richardson. I'll be your pilot for this course. Today I want you to be able to learn why people use statistics, as well as some basic vocabulary and a very important procedure we will use often called solving a proportion. To start off, I'm explaining why people use statistics. It may be obvious to you, it may not be obvious to you. What I've got here is a graph comparing years of school for a person comparing to that person's salary. So if I set the salary here in thousands of dollars, what I want you to see is that for a particular person, let's pick on this individual right here. With 14 years of school, this person's salary comes to be about $25,000. So we've got the point where X is 14 years of school and Y is roughly $25,000 in salary. Not the greatest salary in the world. What we're trying to do here in statistics is make sense of what happens to a lot of people and what the average Jane or average Joe can expect with a certain level of education. What would your salary on average be, would you expect, depending on where you are? What statistics does is it graphs scatter plots like this one, comparing lots of people's education to the salary, and then statistics tries to look at what we call general trends. And if I draw what's called the line of best fit, which would go something like this, then you can see the general trend of the data. As a person's years of school increases, so does a person's salary on average. That doesn't work for every individual, but for a lot of folks in the United States, this is the general case. Now let's talk some basic vocabulary in statistics. We will talk a lot about things like random sample versus biased sample. I have a couple of examples to look at. Example A. Suppose a student interviewed 23 of her neighbors, recorded their responses, and then wrote her findings in a report. Well, student A talked to her neighbors. More likely than not, her neighbors are people that not only she is familiar with, but are people in a similar income bracket to her, and therefore her sample has basically targeted a select group, people who are more or less like her. That's not to say that her neighbors are exactly like her, not at all. But she has excluded people who don't live in a neighborhood like hers. So if we are interviewing neighbors, to interview one's neighbors is basically to create what you call a biased sample, which excludes a lot of people not living like her. Let's look at example B. Here, a student got an alphabetical list of all people in her hometown, interviewed every 20th person on that list, whether they live in her neighborhood or not, and then she recorded their responses and reported on that. Well, for B, she's trying very hard to choose people arbitrarily. And when we choose arbitrarily who is going to be interviewed, and we actually follow through on interviewing every 20th person, well, this comes closer to being what we call an unbiased and therefore a random sample. Two other terms that we're going to make use of are the terms parameter and statistic. A parameter, by definition, is a measurement of a population. So a parameter measures and takes count of numbers in an entire population. A statistic, in contrast, is based on something measuring a smaller sample from a population. So if we select a few people out of a bigger crowd, then the numbers coming from that measurement are coming from a statistics point of view, and that's a statistic. In this example, a team interviewed every resident of all the people in a community. 24% of them were over 60. This number, 76,027, and this percentage from that entire group, those are called parameters. And parameters, again, we associate with population. Parameter, population. I'm trying to emphasize the P there. Population, P, parameter. Whereas, if instead I look at a small selected group, 250 people, chosen at random, even if it's random, that smaller group constitutes a statistic from a sample. 18% of those were over 60. Well, again, these are what we would call measurements from a smaller group, a sample, and therefore, those are what we call statistics. Thirdly, I'd like to note the difference between a discrete variable and a continuous variable. A discrete variable can only take on one of a limited and therefore finite number of values. For example, the rolls on a die. With a die, you can only roll a 1 or a 2 or a 3 or a 4 or a 5 and or 6. There's no other possible roll on a standard 6-faced cube die. In contrast, a continuous variable can take on one of any number of an infinite number of set of values. For example, the height in the water of a pool. The height can start at 0, and then it could be a fraction of an inch, say 1/10 of an inch. It could be 1/20th of an inch. It could be 0.389 inches high. Hopefully, we will have more water in the pool, but if it can go any number from 0 to, say, 10 feet, if, for example, that number could be 3.184 inches, well, that makes for what we call a continuous variable that can take on any one of an infinite number of values. Lastly, I want you to have the ability to solve a proportion. A proportion. Well, a proportion is an equation in which one fraction or percentage is equal to another. So here is an example of a proportion. And in this example, we have 18 over 150 equals 300 over n. Well, in any proportion, here's what is true. The cross product here, 18 times n, equals the cross product there, 151 times 300. If I want to be able to solve this equation for n, well, I need to undo the multiplied 18, and the way we undo multiplication is by division. So we will end up dividing both sides of this equation by 18, and maybe you remember in grade school, in class saying, oh, 18 cancels with 18. Really, that's 18 divides with 18 to create 1n, and that 1n will equal 151 times 300, all divided by 18. And on a calculator, that works out to be approximately about 2,516. And if I want to get more exact, there's a repeating 6 on the end of that. And that would be the solution to this proportion for the number n. Thank you for spending time with me.